Congratulations on achieving such a high score on the Journeyman's exam. It's excellent that you found the platform helpful in preparing for the exam. As you move towards the Master Electrician exam, continue to build upon the foundation you've already established. Focus on utilizing resources to access comprehensive study materials, practice questions, and seek expert guidance. Remember that becoming a master electrician is a continuous journey, requiring you to stay engaged, keep learning, and actively seek opportunities to expand your knowledge and skills in the field. Electrical systems are complex and require thorough understanding. Consider these key areas as you prepare. Firstly, grounding and bonding, which are essential for electrical safety. Grounding ensures a low impedance path for fault currents, protecting people and equipment. Secondly, overcurrent protection. Understanding circuit breakers and fuses, their coordination, and how they protect against overloads and short circuits is critical. Thirdly, wiring methods and materials, which cover the different types of cables, conduits, and wiring techniques allowed by the National Electrical Code, or NEC. Familiarize yourself with the appropriate applications for each. Fourthly, electrical calculations, which include load calculations, voltage drop calculations, and conduit fill calculations. Mastering these calculations is essential for designing safe and efficient electrical systems. Fifthly, motor controls. Understanding the different types of motor starters, overload protection, and control circuits is important for industrial and commercial applications. Sixthly, transformers, which are used to step up or step down voltage levels. Understand transformer connections, voltage ratios, and impedance. Seventhly, safety practices. Always prioritize safety when working with electricity. Familiarize yourself with lockout/tagout procedures, personal protective equipment, and safe work practices. Let's elaborate on each of these key areas, beginning with grounding and bonding. The purpose of grounding is to provide a low impedance path for fault currents to return to the source, thereby tripping a circuit breaker or blowing a fuse to de-energize the circuit. Bonding ensures that all metallic parts of an electrical system are at the same potential, minimizing the risk of electric shock. The NEC, specifically Article 250, provides detailed requirements for grounding and bonding. Key concepts include the grounding electrode system, which includes items like ground rods, metal water pipes, and concrete encased electrodes, and the equipment grounding conductor, which connects non-current carrying metallic parts of equipment to the grounding system. Proper grounding and bonding is essential for electrical safety and is a critical aspect of electrical installations. Next, overcurrent protection is designed to protect electrical circuits and equipment from excessive current, which can cause overheating, damage, and even fire. Circuit breakers and fuses are the two main types of overcurrent protection devices. Circuit breakers are electromechanical devices that trip and interrupt the circuit when an overcurrent is detected. Fuses are one-time devices that melt and open the circuit when an overcurrent occurs. The NEC requires that overcurrent protection devices be sized appropriately for the circuit they protect. This involves calculating the ampacity of the conductors and selecting a circuit breaker or fuse with a rating that does not exceed the conductor's ampacity. Coordination of overcurrent protection devices is also important to ensure that only the affected portion of the circuit is de-energized in the event of a fault. Moving on to wiring methods and materials, the NEC specifies the types of wiring methods and materials that are permitted for different applications. Common wiring methods include, firstly, non-metallic sheath cable, often referred to as an M cable or Romex, which is commonly used in residential wiring. Secondly, electrical metallic tubing, or IMT, which is a thin-walled conduit used in both concealed and exposed locations. Thirdly, rigid metal conduit, or RMC, which is a thick-walled conduit used in harsh environments and for underground installations. Fourthly, flexible metal conduit, or FMC, which is used for connecting equipment and for short runs where flexibility is needed. The NEC also specifies the types of conductors that are permitted for different applications. Conductors are typically made of copper or aluminum, and they are insulated with various materials such as thermoplastic, thermoset, or rubber. The ampacity of a conductor depends on its size, insulation type, and the ambient temperature in which it is installed. Now, electrical calculations are essential for designing safe and efficient electrical systems. Some common electrical calculations include firstly load calculations, which determine the total electrical load that a building or circuit will be subjected to. This involves calculating the demand factors for different types of loads, such as lighting, appliances, and HVAC equipment. Secondly, voltage drop calculations, which determine the amount of voltage that will be lost in a circuit due to the resistance of the conductors. The NEC specifies the maximum allowable voltage drop for different types of circuits. Thirdly, conduit fill calculations, which determine the maximum number of conductors that can be installed in a conduit. The NEC specifies the maximum allowable conduit fill for different types of conduits. Motor controls are used to start, stop, and control the speed and direction of electric motors. Common types of motor starters include firstly, direct online starters, which connect the motor directly to the power supply. Secondly, reduced voltage starters, which reduce the voltage applied to the motor during starting to limit inrush current. Thirdly, variable frequency drives, or VFDs, which control the speed of the motor by varying the frequency of the power supply. Overload protection is essential to protect motors from overheating due to excessive current. Overload relays are used to detect overcurrent conditions and trip the motor starter to de-energize the motor. Control circuits are used to control the operation of the motor starter and other motor control components. Control circuits typically use low voltage control signals to operate the motor starter. Transformers are used to step up or step down voltage levels in electrical systems. Step-up transformers increase the voltage, while step-down transformers decrease the voltage. Transformer connections determine the voltage and current relationships between the primary and secondary windings. Common transformer connections include firstly delta connections, which are used in three-phase systems where a neutral conductor is not required. Secondly, Y connections, which are used in three-phase systems where a neutral conductor is required. Transformer voltage ratios determine the relationship between the primary and secondary voltages. Transformer impedance is a measure of the transformer's opposition to the flow of alternating current. Safety practices are paramount when working with electricity. Always follow safe work practices to minimize the risk of electrical shock and other hazards. Lockout/tagout procedures are used to de-energize electrical equipment before it is worked on. Personal protective equipment, or PPE, such as rubber gloves, safety glasses, and insulated tools should be used to protect against electrical hazards. Never work on live electrical equipment unless it is absolutely necessary. If you must work on live equipment, use extreme caution and follow all safety procedures. Consider specific NEC articles such as Article 210, which covers branch circuits, including requirements for the number and type of branch circuits in dwellings, the rating of overcurrent protection devices, and the types of receptacles that are permitted. Article 215 covers feeders, which are the conductors that supply power from the service equipment to the branch circuit or overcurrent devices. Article 220 covers load calculations, which are used to determine the size of the service entrance conductors and the capacity of the electrical system. Article 230 covers services, which are the conductors and equipment used to deliver power from the utility to the building. Article 250 covers grounding and bonding, which are essential for electrical safety. Article 300 covers wiring methods, including requirements for the installation of conductors and raceways. Article 310 covers conductors for general wiring, including ampacity ratings and installation requirements. Article 400 covers flexible cords and cables, including permitted uses and limitations. Article 430 covers motors and motor circuits, including requirements for motor starters, overload protection, and control circuits. Article 450 covers transformers, including installation requirements and protection. Article 500 through 516 covers hazardous locations, which are areas where flammable gases, vapors, or dust may be present. These articles provide specific requirements for electrical equipment and wiring in hazardous locations. As for mathematics, Ohm's law is a fundamental principle in electrical engineering that describes the relationship between voltage, current, and resistance in an electrical circuit. The formula for Ohm's law is volts equals current times resistance, so volts equals amps times ohms. This law states that the voltage across a conductor is directly proportional to the current flowing through it and the resistance of the conductor. The power formula is used to calculate the power consumed by an electrical device or circuit. The formula for power is power equals volts times current, or power equals volts times amp. This formula states that the power consumed by a device is equal to the voltage applied to the device multiplied by the current flowing through it. Kirchhoff's laws are a set of two laws that describe the flow of current and voltage in an electrical circuit. Kirchhoff's current law, or KCL, states that the sum of the currents entering a node, or junction, in a circuit is equal to the sum of the currents leaving the node. Kirchhoff's voltage law, or KVL, states that the sum of the voltages around any closed loop in a circuit is equal to zero. These laws are used to analyze complex circuits and to determine the current and voltage in different parts of the circuit. Understanding three-phase power is crucial for commercial and industrial electrical systems. Three-phase power is a type of alternating current, or AC power, that uses three conductors to deliver power to a load. Three-phase power is more efficient than single-phase power and is used to power large motors and other high-power equipment. There are two main types of three-phase connections. Firstly, delta connections, where the three phases are connected in a triangle configuration. Secondly, Y connections, where the three phases are connected in a star configuration with a neutral point in the center. Single-phase loads can be connected to a three-phase system by connecting them to one of the three phases and the neutral conductor. When working with electrical blueprints, they provide a visual representation of an electrical system, including the location of electrical equipment, wiring, and other components. Electrical blueprints typically use symbols to represent different types of electrical equipment and wiring. It is important to be able to read and interpret electrical blueprints in order to install and maintain electrical systems correctly. Common electrical symbols include, firstly, outlets, which are represented by a circle with a line through it. Secondly, switches, which are represented by a circle with a curved line. Thirdly, lights, which are represented by a circle with an X through it. Fourthly, panels, which are represented by a square or rectangle. Electrical codes and standards provide a set of rules and guidelines for the safe installation and maintenance of electrical systems. The National Electrical Code, or NEC, is the most widely used electrical code in the United States. The NEC is updated every 3 years and is based on the latest research and best practices in the electrical industry. Other electrical codes and standards include those developed by organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. Staying up to date on electrical codes and standards is essential for ensuring the safety and reliability of electrical systems. Effective troubleshooting techniques are essential for identifying and resolving electrical problems. Common troubleshooting techniques include, firstly, visual inspection, which involves looking for obvious signs of damage or wear. Secondly, voltage testing, which involves using a voltmeter to measure the voltage at different points in the circuit. Thirdly, continuity testing, which involves using an ohmmeter to check for continuity between different points in the circuit. Fourthly, insulation resistance testing, which involves using a megameter to measure the insulation resistance of conductors. When troubleshooting electrical problems, it is important to follow a systematic approach and to use the appropriate tools and equipment. Renewable energy systems, such as solar and wind power, are becoming increasingly popular. Solar power systems use photovoltaic, or PV, cells to convert sunlight into electricity. Wind power systems use wind turbines to convert wind energy into electricity. Renewable energy systems can be connected to the electrical grid or used to power off-grid applications. The installation and maintenance of renewable energy systems requires specialized knowledge and skills. As for energy efficiency and conservation, it is becoming increasingly important to conserve energy and reduce our reliance on fossil fuels. Energy-efficient lighting, appliances, and HVAC systems can help to reduce energy consumption. Building automation systems can be used to control lighting, HVAC, and other building systems to optimize energy efficiency. Regular maintenance of electrical systems can also help to improve energy efficiency and reduce energy waste. Specific equipment includes the following. Multimeters are used to measure voltage, current, and resistance in electrical circuits. Tampon ammeters are used to measure current without having to disconnect the circuit. Insulation testers, or megameters, are used to measure the insulation resistance of conductors. Ground resistance testers are used to measure the resistance of the grounding system. Thermal imagers are used to detect hot spots in electrical equipment. Power quality analyzers are used to measure voltage, current, and power quality parameters. As you study, review relevant articles from the NEC, such as Article 220 for load calculations, Article 250 for grounding and bonding, and Article 310.15 for conductor ampacity. Practice applying these calculations and understanding the code requirements. For example, practice calculating the minimum size conductors for a residential service using the standard calculation method outlined in NEC 220.82. This involves determining the general lighting load, small appliance and laundry loads, and any other specific loads such as ranges, dryers, and air conditioners. Then apply the appropriate demand factors to these loads to arrive at the total service load. Once you have the total service load, you can use NEC Table 310.15b16 to determine the minimum size conductors required for the service entrance. Additionally, understand the requirements for grounding and bonding the service equipment as outlined in NEC Article 250. This includes properly sizing the grounding electrode conductor and bonding all non-current carrying metal parts of the service equipment. For motor circuits, calculate the full load current, or FLC, for motor using the formula FLC equals horsepower times 746 divided by volts times efficiency times power factor. Then, determine the appropriate size of the motor starter, overload protection, and branch circuit conductors based on the motor's FLC. Understand the requirements for motor disconnecting means and short circuit protection as well. As you progress in your career, consider continuing education courses on advanced electrical topics such as power quality, motor controls, and renewable energy. Staying up to date on the latest technologies and code requirements is essential for success in the electrical field. Remember to prioritize safety in all aspects of your work, and never hesitate to ask for help if you are unsure about something. With hard work and dedication, you can achieve your goal of becoming a master electrician and have a successful career in the electrical industry.